I'm Steve Skeena. I'm the one that's teaching this course. I am sorry I had to miss the first week of classes. I hope Saba and my students took care of the place okay. Is that okay? Any questions about the course administration before we go any further? Okay, how the course is going to run or anything like that? Okay. I know I went through the what syllabus. I've got copies of the syllabus here if anybody hadn't picked one up, but that's the rules there. Any questions? First thing, let's say, Mahan, come down here for a second, okay? We now have TAs. Again, Saba was the first TA we were given. We now have 4 TAs for the semester. This is Mahan. Everyone give Mahan a round of applause. Okay. Now, are you allowed to abuse him when it comes to grade, regrade attempts or anything like that? Answer is no. He will be diligently grading your assignments. He will do everything he can to get it right. If he gets it wrong, we shrug and we move on. Is that clear? Okay, fair enough. Okay, at this point, go do your other things. Okay, he's got other things to do, including helping prepare for the quizzes. Starting today, we are shaping up for the quizzes. So we're now going to, every class there will be a quiz. Every, the quiz will start on Wednesday at some time. And it will be due before class today, before class the next day. So you come into class, you haven't done the quiz yet, the quiz is over. Is that clear? And do you complain if you miss one of the quizzes? You do not complain if you miss one of the quizzes. The quizzes you have to get done before the class starts. Question, yes? The quiz is ideally going to be on the previous lecture. That is the idea, okay? The quizzes count for a tiny bit of the question, okay? If you're doing really well on the quizzes, what does it mean? It means you've sort of been attending to class. It's not a, the quizzes are not designed to be too much of a challenge. They're designed to be something to keep you basically alert with what we're going on as we move through the semester, okay? Rather than people getting to a point where, the midterm comes and, oh, what did we study this semester, okay? That's I guess, the goal. Any questions? And of course, if you want, yeah, question.
The quizzes will be only on the last class or all previous class?
The quizzes will be on, hopefully, the last class. Actually, in general, the last class, okay? This time, I'm hoping that there will be a couple of questions from a class before, but we will see, okay? Again, the quiz is just designed to keep you alert, okay? Not to be a tremendous intellectual challenge, okay? Any questions about that? Okay. Now, the quizzes. One change that I think is happening, and I want Mahan to tell me that this is nod when I say what I'm saying is true. We are shifting the quizzes to Brightspace. Is this true? Yes. Okay, so I made a lot of noise about Google Classroom. Okay, I still am likely to make you submit your projects and your homeworks through Google Classroom. The TAs have convinced me that they can handle the quizzes on Brightspace. Okay, so you need to look out. What time will the quiz be available today? I mean, tomorrow. It'll be tomorrow at, we don't know. So how do you find out? Oh, that's a good question. Well, one possibility is to look on Brightspace, perhaps. The other is to look out on Piazza, where there will be course updates. Okay? So supposedly on Piazza, there will be an announcement at some point saying, hey, the first quiz is ready. And we will assume that that will then be ready at this time every day. What happens if you go to try to find the quiz and you can't find it? What should you do? Does anybody have an idea? Email is one possibility, but there's a better possibility. Can anyone think of a better possibility? Piazza. You email, you get the answer, nobody else gets the answer. Okay? If everybody emails, I or the TAs have to answer 183 emails. Okay? The right answer is we do it on Piazza, right? So it's perfectly great if at 6:01 you guys start sending polite but firm messages. I can't find the quiz. It's after 6 o'clock on Wednesday. I can't find the quiz. How do I do this? Okay? Does everybody get that idea? That's how we communicate. Yeah, again, if you have individual questions, I'm delighted to talk to you. But I think that things that are likely of interest to other people, Piazza is the right thing. Yes? You will expect a quiz Monday evening, Wednesday evening. And you have to do it before the next class. Okay? And just a habit I want people to get into. Yes?
Is there a time limit on how soon you need to finish the quiz once you start it?
I don't believe so. But the quizzes are not intended to be long exercises. And if you feel you want to try to look up answers on the notes or something, that's fine. Okay? But yes?
And can you retry up until the deadline, or is it once submitted and done?
I believe I'd like it to be once and done. Okay? The stakes are not so high that if you get a quiz answer wrong, it doesn't really matter in the big picture, right? Quizzes are 5% of your grade. There are going to be 25 of them. They're going to be big old 4 questions on every, quiz, okay? If you get a couple of answers wrong on a quiz, or maybe even an answer wrong on every quiz, it doesn't matter that much, okay? You don't do the quizzes at all, it matters. Yes?
When the quiz will open and how long it will take time?
How long will it take time? I believe it will take 4 to 5 minutes, okay? Now, could you do it faster? If you answer randomly, you could certainly do it faster. Okay, could you do it slower? I'm sure if you put your mind to it, you can take more. But this is intended to be a quick check-in. It's not intended to be a cognitive exercise. Any questions about that? Any other questions about the quizzes? Okay, who here is not yet on Piazza? Has not yet signed on to Piazza? Okay, who is not registered for Piazza? Okay, all of you better register for the Piazza. And it's now called Fall 2024, so you want to make sure you're on the right Piazza thing. There was some glitch at the beginning. Okay, I should have closed off the old Piazza one. But get on there and prove that you're on there. Any questions? Okay. Any other questions about the course logistics? Next class, we're going to give out the first homework assignment, which is starts to be a real thing, but we'll deal with that then. Okay. Anything else? Okay. So today, I'd like to start talking about data science as I see it. Okay, and maybe this class lecture is going to get more philosophical than other lectures. So if you start hearing me drone about my opinions, this will be more true here than at other points. So don't get too scared. And I do want people to be asking questions or interacting here. This is important. The room we're in this year, I know people like this. Who likes this classroom? Who doesn't like this classroom? Okay. Now, I am used to teaching in a big, classy, fancy classroom, Fry Hall 104, that is beautiful, and it's big, and it's all white walls and stuff like that. And I hate that room because the students are very far away. It's like it's lecturing to a stadium. Here you guys are in my face, and this I like. Okay, so I want there to be questions. I want there to be interaction in here. Okay, any questions about that? Okay, so what is data science? As I think about data science, I think of it as, let me see if I can move this dot someplace. Is that a better place for the dot? Good. Okay, it's kind of, data science is kind of a field that emerged at kind of the intersection of statistics and computer science, and it has a lot of elements of things that we're going to talk about in here. It has to do with exploratory data analysis. How do you look at a data set and make it, make sense of it? That's visualization. It has to do with machine learning and statistics. I know these days everybody wants to be doing generative AI, and they know that that's from machine learning. A lot of the machine learning we're going to be doing in here is lower tech, old-fashioned machine learning. Okay, because I think a lot of what want to do in here is modeling, and modeling, for science, for trying to get some kind of an understanding of a phenomena. It's also about sort of high-performance computing technologies. One of the things that made data science interesting was when data sets started getting much, much bigger. In the old days, there was statistics, okay? And statisticians did deep things on data sets of 100 points, okay? Now, as technologies have improved, people are dealing with really massive data sets. And kind of when I think data science emerged when you started having really large data sets, and the techniques that classical statistics used weren't the way to make the most sense of them. So this is a kind of Venn diagram of data science that I kind of like. In general, a data science project should exist at the domain intersection of three things. As I said, computer science, statistics, and is usually a field or an application whose data you're working with, which is of importance to them, okay? If you just have computer science and statistical analysis, but you don't care about the domain, I put that as actually machine learning. Historically, when you read machine learning papers, you will see a typical machine learning paper would proudly say, here are my F1 scores on 10 different data sets. Did they care about the data set? Not really. They cared about the F1 score. See, my F1 score is better than your F1 score, okay? And there is a difference here. In kind of when I think about data science, I think there is a problem for which you want to use the data that is, to learn something. That's kind of where I think the interesting stuff traditionally is. The intersections here are I find kind of interesting labels. Traditionally, if you go into the sciences, you had people who sort of knew something about math and statistics. They cared about their field. Maybe it was biology. Anyway, this is, I think, a representation of the world. And hopefully, we're going to try to operate at the intersection point. Now, one thing that I find from, years of work, working with computer science students is historically computer science students do not appreciate data, okay? Data is the stuff that runs through a program, okay? That is kind of historically, I think if you grow up as a traditional computer scientist, that's what you think data is. Now, has anyone ever done experiments on an algorithm where they generated random data and pumped it through the algorithm to test it? You see some people. Now try to explain that to a scientist, what you're doing. You're saying, I see, you write a program, you generate random numbers, and you run the program on your random numbers. What are you learning? Okay, why are you doing this? You probably did it to see how fast the program ran, okay? Was there any other reasons why people did something like that? Yeah?
So that, I was working on the ML model, so I generated random data so that the model doesn't overfit on the data.
Okay, so you're sort of saying that you added random data to the real training data, so the model got worse.
Yeah, it wasn't the training data, it was a satellite data, and it was based on time, so temporal context. So I didn't want the model to learn from the time, so I had to put random data.
Okay, so this is a little different than the case that I'm talking about. Again, they're interesting questions of how you train these things, and one of the things about the the new generative AI world is to what extent can or should you use generative models to generate data to train other models. Okay? So that's not, that is an area that people think about in some serious way and may or may not be, be crazy. But again, if I think about it in terms of data science in general, when I think of a data set, I am thinking of something that you have lovingly created, that you spent a fair amount of resources to try to acquire, okay? And I think computer scientists tend to underestimate the hard work and imagination that is required to get good data sets, okay? Maybe this is less so today than it used to be, but that's my feeling. One thing just before I get as a caveat, can anybody figure out why the students that come in late come in packs? Okay, part of what we're going to do in this class is talk about statistical distributions. Okay, what is the normal what would people think of as a distribution in a normal world? If I wanted to think of what is the time, let's say we had do I have chalk or something? Let's see if I have chalk. If I wanted to draw a distribution where this is the frequency and this is time late to class, time before class, 0 is the time class starts, what would we think that this distribution should look like? In life and practice. Does anybody know about shapes of it? Yeah.
It should be like a normal distribution, but slightly skewed.
Okay, so I would say a normal distribution is the kind of thing. Slightly skewed towards the left. You say people work harder to come early to class than to come late, okay? That may or may not be a reasonable assumption, but okay. Now, is that what we're observing in this class? Okay, no. What are we seeing? We're seeing worlds where, if I were to look at what that real distribution is, it's probably in this class something like, I'm going to guess, okay, let's say you tried to come early in general, and there's going to be something like this, okay? Why are there those bumps? Okay, I know why there are bumps, yes?
Like
the buses, okay? Now, I'm going to let you know something. I am 63 years old. I walk to work, okay? And I actually pretty much pass where the grad dorm is every day on my way to work. Walking is good is good. And so I encourage people to walk if they can. If not, I understand that taking the bus can sometimes help. Any questions about distributions? Okay, good. Okay, so let's get back to the difference between scientists and computer scientists. Scientists that I know of live in a world that is, they try to understand how the real world works. They're looking at messy things in data. They are looking at phenomena like those bumps at the right and trying to explain them. Okay, maybe they're biologists and they want to know how cells work. Okay, computer scientists live in worlds that they designed and are kind of clean. Okay, is you guys program in Python? Was Python given to you by nature? Does Python ever not do the right thing? Okay, no, Python has a well-defined model of what it does. It always does the same thing. Okay, you are comfortable living in that. Do you guys even work on real computers anymore? Many of you are saying, no, I use a virtual machine. A real machine is too dangerous and too unpredictable. Okay, now we live in virtual machines. Okay, so this is different than the world that scientists live in. Okay. Scientists, especially people in the natural sciences and the social scientists, do not live in worlds where everything is true or false. There is experimental error. There is a messy thing. When I collaborate with biologists, I talk to them, I said, how does this work? They explain it. And then I ask them, is this how it really works? He says, well, there's also this thing, and this isn't quite true, and da-da-da. We come from a world where every bit is 0 or 1. Everything is true or false. And this is a different way of thinking than a statistical way of thinking. Okay? Any questions about that? And again, I like there to be interaction. I don't want to be, completely focused here. Real scientists are data-driven. I don't know if any of you have friends in the chemistry department or the biology department. They will work hard. They will pull their all-nighters doing experiments, desperately trying to get a small number of data points. Okay? Computer scientists tend to be algorithm-driven. They don't really care what the data is that they're going through it. One other cultural difference is that scientists try to discover something. If you say, what does a scientist do? Okay? They want to be the first person to do something, the first person to discover a new law of nature, okay, or how something works, what this gene does, okay? Computer scientists don't discover things, okay? Maybe you might argue some people in theoretical computer science discover certain principles, whether that's math or, math is quite, mathematical discovery is the same thing we can have a philosophical discussion about. Computer scientists tend to invent something, okay? And, that generally, patents in computer science are not that important, okay? You hear about all the machine learning stuff. Obviously there's a lot of money in machine learning now, right? You don't hear, I don't know if any of you have heard, I don't remember any case in the last, reading the newspaper where a patent fight was an important thing between OpenAI and some other company, right? Patents aren't that important in computer science. I mean, if you hang around the company will probably apply for patents. Generally, that's to make sure they're not sued by other people. But in other in like the drug company world, the pharmaceutical companies, they discover new compounds, they invent a new compound, they patent it. A patent is the only thing that matters to them, okay? We will reinvent things rather than, it's not that hard. If I tell you, here's an algorithm for sorting, you can't use it, what do? You come up with another algorithm. You rewrite the program, so it's a little bit of a different way of thinking. And the final thing is, I think that scientists, especially experimental scientists, are comfortable with the idea that data has error, okay? Historically, when a computer scientist writes a program and the input file format is slightly wrong, what happens with the program? It crashes, right? Okay, this is a different way of thinking. And when you're dealing with, experimentally drawn, human-drawn thing, there are certain kinds of errors that we have to worry about. Okay, any questions or comments, discussion? Okay, one more bit of philosophy here is that there is a difference between what I will call genius and wisdom, okay? Now, Isaac Newton was a genius, okay? He came out and discovered things and thought of things that no person had come close to thinking about before. How on earth did he do it? Maybe he got hit by an apple. I don't know what the story was, okay? Now, he was also crazy in many ways, and if you read this history of Isaac Newton, he did he spent most of his life chasing some kind of, religious, philosophical stuff that was from today's point of view, looks strange. You wouldn't consider Isaac Newton in general a wise person. Genius in computer science is about finding the right answer. The guy who's the algorithm person who solves this problem that nobody else can solve, that person we think of as genius. Wisdom is something that happens in avoiding errors, okay? Your grandparents are wise people, okay? Why are they wise? Well, it's probably not that they think of incredibly deep things and do this thing. It's that they tend to not do stupid things. They know when you're about to do something stupid, okay? They avoid doing wrong things, okay? And when I teach algorithms, I'm trying to teach people to be geniuses, In data science, I'm trying to teach you to be wise. I'm trying to teach you to avoid doing stupid things, okay, that will kind of make the answer wrong in the end, okay? Any questions about that? Okay? So how do you become wise? Okay? Well, one thing is experience. That the more data science in life, the more things you do, the more experience you have, you become wiser. That's why your grandparents were wise, right? They had more experience. I believe that wisdom comes from general knowledge, okay? That knowing more than just, let's say, computer science. If you spend your whole life becoming the ultimate computer scientist, odds are you're not going to know much about the rest of the world and you're not going to be wise. Wisdom comes from listening to others, okay, because other people have anything. Wisdom comes from knowing when you are wrong, okay? One of the great formative experiences of my life was trying to produce a gambling system to predict football games, okay, American football games. And what do you discover when you build a very clever system to predict football games? Your predictions are often wrong, okay? And you start realizing, you start thinking, why is this? When you start making predictions and you get this, and if you evaluate yourself, you see when you're wrong. And if you're wise, you learn from that. And so hopefully this course you will start the process of developing wisdom. Any questions? Okay. So one thing that is a good practice in life, in data science and other things, I think is learning to develop some curiosity. Okay. Actually, I know most of you have probably worked in. How many of you worked for companies that kind of did something outside of computer science? So again, if you're saying, I worked for General Motors, they did cars. You were doing computer science, but they were doing cars, right? How many people worked for a company that was not a strictly computing company? Okay, I'm seeing about half of you. Now, how many of you were interested in what the company was doing? Okay, hopefully all of you, okay? But a good data scientist is curious about what their domain is, okay? They like to talk shop with the people that are doing it, okay? If you meet a real car company, okay, you would, if you're working in this, you're working for General Motors, let's say, and they're doing some data processing stuff for them, and you meet a real car guy. Oh, what happens in a car factory? How often do things break down? They ask questions. They like to get involved with this. Okay. I also think that a curious person reads the newspaper every day. Okay. Now I actually do, for technical reasons, subscribe to a paper newspaper. I do read it online. It's not quite that thing. Reading online counts as reading a newspaper. But reading a newspaper where you're reading through the whole front page, to know what's going on in the world is very important. And I think that that's helpful to get a perspective on understanding things. And I strongly encourage that if you do it or don't do it. Any questions about curiosity? Okay. One thing that curiosity is about asking questions. And my claim is many of you are software developers at heart, okay? Software developers, I say, are generally not encouraged to ask questions, okay? Who here has ever been given a specification for the program to write, that they have to write? Has anybody ever had a job where they were given a specification? I'm surprised it's not more of you, but yes, you're told this is what you're supposed to do, okay? Or you say, oh, we can change it and it'll do better. What will they tell you? They say, do the specification. You are not, why are we doing it this way? Shut up and do the specification. This is what the program has to do, right? Okay? Now, data scientists are encouraged to ask questions, okay? First of all, you need to understand your domain as much as you can. So the kinds of questions that I want you guys to ask now are about things, or learn to ask, oh, this company has all this data. What can you do with it? What exciting things can you learn from it? What are the things that the company people really want to know? They may have an idea, or they may not really have an idea of what they want to know, and because they don't really understand their data set well, they don't understand what the potentials are. What data sets might get you there? These are kind of good data science questions. And so what I'd like to do for the rest of class is to go through and have us pretend that we're scientists, okay? And have us pretend that we are, going to practice answering questions. I'm going to talk about a bunch of different data sets. And I want us to think about what kinds of things could you do with it, okay? That's kind of the lesson for today, is to realize that their data sets are kind of interesting things. They have lots of answers locked within if you know to ask the right question. Okay, so the first data set that I'd like to, any questions about where we are or anything like that? Okay, good. So my first question, data set I'm going to talk about, is about baseball. Now, how many people here are longtime baseball fans? I see almost zero, okay? How many people are longtime cricket fans? Oh, okay. So baseball and cricket are, to a first approximation, isomorphic, okay? I don't expect to make you care about baseball, okay? But on the other hand, the data scientist is supposed to get interested in things that are in the world around them. Why is baseball interesting? That'd be a kind of a question a data scientist should ask with this. I don't know if did you want to answer that question?
Yeah, it's the statistics and the history bit of all the players that come before and how it's changed over time, looking at the history.
Okay, so one thing that's interesting about baseball compared to other American sports is it has a very long history of play under grossly the same rules. Okay, baseball, you can say when is the birth date of modern baseball. You might say 1901, you might say 1869. But an interesting thing is that there's a statistical record that goes back a long way, and the rules are grossly the same. Not exactly the same, but grossly the same enough. So Baseball Reference is a website that I will confess I'm a baseball fan. And what does it have data on? It has data on individual players. Who here has ever heard of Babe Ruth? A few of you. He was like the Sachin Tendulkar of baseball. Okay, he's arguably the greatest player ever. What do we know about it? And they have this for every player who's ever played. What do we know? We know their name, their height and weight, whether they threw left-handed or batted left-handed or threw where they were born, when they went to school, when they died. We have access to biographies of them in text. We have baseball players sometimes get traded from one team to another. Yeah, you see the mouse, okay? We have what their record of when they were being paid. Again, this was showing his salary. At the time when he played, $80,000 was big money. There's stuff like that. What else do we know? We know for every player, not only their life story, but we also know something about their play. We have their statistics of every year that they played. Okay, how many hits and how did they perform over the course of the season? The dark numbers meant that they had the best record in their league in that statistic. So see Babe Ruth leading in home runs all the time, and walks all the time, and slugging all the time. He was really great, okay? But there's a statistical record here. What teams did they play with? What awards did he win? Stuff like that. So my question for you is, now that you have this data, what could you do with it? Suppose I give you the data on every single person who's played baseball in history. What do you do with it? Is there anything interesting you can do with it? Yeah. What? Say that again, I couldn't hear.
I said query.
Queries.
Yeah.
Queries means what?
I mean, for example, I'm searching for just an existing report.
Okay, so now what you're saying is, you're thinking in terms of, oh boy, could I build a website so people can look up what their favorite player is? Now that's a fine application. I'm now asking kind of a different, that's a computer scientist answer, okay? A real scientist answer would be, what do I use this data? What kind of questions about the world could I figure out? So that's the domain that I want us to be thinking about now.
You could do some simple data analysis with it and find out the average height and weight of.
Okay, so one question would be about heights and weights. Now, is there something, what interesting things might you learn about people's heights and weights from this? Okay, yeah?
You could see how people grow bigger and faster.
First of all, have people grown bigger and people, athletes grown bigger since Babe Ruth was in, he started playing in the 1914, okay? Have people grown bigger? Actually, if anyone's ever seen photographs of Babe Ruth over time, he grew bigger over time, right? Okay, he was a fat guy at the end. But yes, did people grow bigger? What other things with heights and weights might be interesting to learn?
No, I had a different application. Like you could analyze the performance of a particular.
Okay, hold that for a second. What else could you, I'd be curious about, for example, how do they compare to the general population? Our baseball players at that time, were they big guys? Okay, you might imagine that these were athletes at the time. Were they bigger, heavier than the general population? This feels like an interesting thing. Okay, what was that?
Basically, you could analyze the performance of the player over the years when he started.
So analyzing performance of the player over the years. Now, what are you going to do with that? Okay, so one question, what kind of, let's say, science-like question might you want to ask, okay, with that? Okay, what does that mean to analyze play over years?
How does age affect his performance?
How does age affect performance, right? Okay, you can imagine as you age, imagine actually probably as a young player, when you're too young, you're probably not as good as when you get older. And then when you get old enough, then and so the question of what is the aging curve on skills? This is interesting. I'm a professor, okay? I'm now an old professor. How is my performance degraded with time? That's harder to measure, okay? Some of you may be saying, well, a lot. But that's harder to measure. In a domain like sports, this is a domain where you can learn about a real phenomena, okay? Any other things you can do with this data? Yeah?
Sort of analysis of like playing time and their career time, like from 1914 to like 2024, like the time span they play for, because nowadays players play less.
Okay, so there's a question of how long are careers, okay? You might imagine that that there's a distribution of careers. Babe Ruth was a very good player, okay? He played 22 years, okay? And he started pretty young, okay, in the major leagues. There are players more recent than him who played longer careers. Not quite as good, but good enough to keep earning a paycheck, okay? So the question of how has the career length changed, okay? And that I can see as an interesting phenomena. Any other phenomena? I'd like to move this around. Yes?
Maybe because there's data spanning so many years, you can compare the best player in different eras.
So trying to figure out who's the best player. Is there a measure of value of who's best? Okay? Now, what does that mean in data science terms? Okay? Here we've got a lot of record. Trying to figure out how best is somehow a measure of a score of how good you are. That means boiling down all of these numbers to one number, right? And you want to, where better is worse. What's the right way to do that? Okay? If you know something about how good players are, if you had a measure of how good they were, on a scale from 1 to 10 or something like this, or let's say 0 to 100. What would you be able to do with that? Yeah? So you might want to say there are awards, recognitions like the Hall of Fame for the best players. Did the best players, the players that got in the Hall of Fame, were they really the best ones? Or were they people, did they know somebody? I don't, you could imagine a world where there's probably some people who were really great who got in the Hall of Fame, and some people who, when you look at it years later, you say, why did people think this guy was so good? Okay? Yeah.
Average life expectancy, I can check the average life expectancy.
Life expectancy. So this is something that we had on there, their birth and death dates, right? We know how long these guys lived. How has life expectancy changed? Babe Ruth was a great baseball player. He didn't live very long. He lived to I think he lived to 52 or something like that. Okay? So this is some kind of, so the question of how did life expectancy change feels like an interesting thing. Okay, one more, yeah.
I'm not sure if this applies to baseball, but something which is like a good thing in cricket is finding out the strengths and weaknesses. Like certain batsmen prefer hitting the pace bowlers more than the spinners. So I don't know.
Okay, so there's some question here of can you figure out who hits curveballs better than fastballs? Now that's an interesting question perhaps. I don't see how I would do it from this data set, right? Because the data set that I'm showing you so far is based on seasonal records. If you had a finer grained data set, maybe that kind of question can be answered. And that's why these baseball, the baseball teams hire now, they have analytic teams that look at every pitch, and they get tremendous amounts of data to try to get an edge on their team. Okay, fair enough. Okay, I'm going to cut this one. Let's just think. No, actually, I guess I can still have a little time. Okay, a couple more.
Finding the right composition of team members that help win a championship based on their statistics.
Okay, find combinations of teams. So one thing that's true is if you click this tab, you will find the rosters. You'll know which people were on which team which year. By collating that properly, you will know for every team what its players were, and you'll know how the results of the team. Maybe you could figure out what goes into making a good team. Is a good team having the best players? And the answer is somewhat, but not always. Okay, there are different roles. Sometimes there are people who are at certain point not obviously the most valuable people, but you need people to catch the ball, right? Babe Ruth, at the end of his career when he was fat, probably didn't do a great job of running to catch the ball, okay? And so there are different sets of skills, okay? One more, and for real.
Find the correlation between salary and performance.
Okay, salary and performance, okay? Now, this is an interesting question. Do people, we know their salary, we know how good they are. Do people get paid for their current performance, or do they get paid for their past performance? Okay? And how does this change? Okay? This feels like an interesting question. And again, it's hard to tell. It's probably a relevant question in the software industry, right? You guys have salaries. Do you know how good you are compared to your buddy? Okay? It's hard that they get metrics on something like that. Baseball is a domain where you can get metrics. This is a phenomena you can study. Okay? And these seem like interesting questions. This is thinking like a scientist, and this is what I like people to do. Okay, fair enough. Now, what were my questions here? Okay, again, when I was coming up and doing it, most of these were, there's the set of baseball questions, which I think we talked about. One domain we didn't talk about that I think is kind of an interesting question is, how well do trades work out? One thing that the data set has is you can, in baseball, and I'm guessing cricket, does it happen in professional cricket that a team can, can take one of their players and trade them to another team? You know, I sometimes wish I could take some of my grad students and trade them to another university, but it doesn't work that way, right? Okay, but in sports teams it seems to work that way, right? Okay? How fair are these trades? Okay, is it that do teams regularly, you know, some teams know how to rip off other teams, or is it this kind of thing? But there are other questions that are kind of like the ones we've talked about, which I think get into using the data set as a real scientific thing for things outside the world of baseball. So I'm going to go through a couple of examples here. One is that there was a study that was very interesting. Is who here is left-handed? Okay, you know, probably 10% of the people in the room are left-handed. I'm left-handed. There's a question of, do left-handed people live as long, longer or shorter than right-handed people? This feels like an interesting question to tell. Now, could you do this kind of a test? Let's think about how you would do a study like this. They say, well, there's millions of people, we know how old they were when they died. That's fine. Who here knows whether their great-grandfather was left-handed or right-handed? You know?
Yeah.
Why? What?
Because I met my great-grandfather.
Okay, you met him. That's a good thing. Okay, that's a good thing. But in general, the phenomena is I did not meet my great-grandfather. I did not meet two of my grandparents, okay? So I certainly have no idea of whether they were lefty or righty, and it wasn't the kind of thing that gets recorded in general in many places. Does everybody kind of see that? The Social Security Administration knows when you were born and when you died, but they don't know whether you're lefty or righty. So how could you conduct a study on lifespan and this? Well, baseball players, people cared about whether they were lefty or righty, okay? When they were filmed throwing or batting, you could see whether they were lefty or righty. And so based on this, they did a study, do the left-handed people live longer or shorter? The left-handed baseball players live longer or shorter than right-handed baseball players? The answer was the lefties died younger, okay, by about 2 years in the study that they did. Now, it's not clear that this is relevant for us today. You know, part of it is a lot of them, you know, died in things like they were driving tractors designed for right-handed people and fell off the tractor or something like that. So don't worry about it. It's probably not, it's today not as strong a phenomena as it was then. But there was a visible phenomena there. And this is, I think, an example of using a data set for clever purposes. This is the kind of thing I love, when people can use a data set for clever purposes. Yes?
How do you ensure that this applies to the general population as well?
How do I ensure that it applies? So that's a question. Is there a bias that maybe left-handed, you know, that what happens to baseball players does not happen to the population at all? Well, are there biases if we take the baseball population versus the general population? Are there differences? Yeah.
They have a higher tendency to exercise.
You say they exercise, okay. Babe Ruth not at the end so much, right? Okay. Were there any, what's the biggest bias when you take it for just baseball players?
Location, demographic.
Location. What's the biggest bias? Lifestyle. What's the biggest bias? Traveling. What's the biggest bias?
Injuries.
What? Injuries. What's the biggest bias?
They play more baseball than
They play, what's the biggest bias? What?
how much they are.
How about that there are no women who played in the major leagues? Okay? That to me is the biggest. We're talking about lefties versus righties, okay? This is a big bias, okay, for to talk about how general it is. So yes, there's questions of what you generalize, what you don't generalize, okay? On the other hand, it gives you a reference point to start thinking about it, and now you can ask finer questions. The result of the finer questions, are they biased? Does that mean you throw out the experiment, the result you have here? No, but you try to interpret it in the lights of what the biases are, okay? So yes, a better study with a broader population would be better. And in fact, there have been studies after this that seem to make a lot of the bias go away. Okay? Right. Class ends at 10:50, right? It's a slightly different time than it was in the past. I just want to mentally adjust in my head. Okay, one last question here that's kind of interesting. How many of you, okay, I am going to take a look at this room and guess that a non-trivial fraction of you are new to the United States, okay? How many of you, I am going to guess that a non-trivial fraction of you who are new to the United States plan to stay in the United States, okay, at least for a while, okay? And some of you are probably planning that you're going to stay in the United States for a while and eventually move back home, okay? Now, the question of how often do people return home is an interesting question. Many of my students have come to the United States. They live, they get comfortable, decide it's a nice place to be, and they don't ever quite make it back home. They may have thought they were going to do it at some time, but they don't do it. How often do people return to where they were born? Well, the baseball data shows me where they were born and where they died, okay? I can get a good sense of this kind of thing, and whether this is increasing or decreasing with time. My guess in the old days, people didn't move around so much. Probably it was more likely they returned to where they and died there. Okay? But this is a kind of question about the world. Okay, any important questions about baseball? Should I move to another data set? Yes?
I would like to know that what is the difference between the perspectives of, computer scientists and scientists in terms of looking for this data?
Well, okay, so the computer scientist, I claim, will be immediately thinking about how do I write a program to do something? How do I write an application where I can put it on the web and sell ads? That's what a computer scientist is programmed to think. What I will claim is that a disciplinary scientist will be programmed to take a look at a data set and say, what can I learn about the part of the world that I care about? If you are a biologist, maybe you're interested in lifespans, okay? If you are a demographer, a social scientist, maybe you're interested in mobility patterns and immigration and stuff like that. So, there's a domain, there's a world where either you're interested in a substantive question or you're interested in an application. Again, I'm not trying to tell you guys stop being computer scientists, okay? But I am trying to sensitize you to that there is a world for using data that is different than than we usually think by nature. Okay, let's go to another data set. This is IMDb. Okay, how many people have used IMDb on the web? It's the movie database. Everybody knows about it. Okay, what is an IMDb? There is a record for every movie that ever, kind of whatever they consider to be a movie, it's on there. My data science TV shows are not, I noticed on that, but of course that's never been broadcast or anything like that. But what do they tell you about a movie? How many people are familiar with the movie It's a Wonderful Life? None of you? Okay. Come Christmas, this is the best Christmas movie ever made. So when you're in the United States around Christmas, make it a point to watch it. What's this movie story? We know when it was made. We know what its title was. We know some text about what it was about. We know the directors and the stars. We know how much money it made. Okay? So we know a lot about the gross stuff of the movie. We also know stuff about each actor in the movie. Okay, here was Jimmy Stewart, who was kind of the Tom Hanks of his day. We know when he was born and when he died. We know his biography. We know where he was born and died. We know the cast of the movie, who he was with, and stuff like that. Okay? And so for every actor in every movie and every director and every such and such, we know what projects they were involved with. What can you do with the data from IMDb? Is there any interesting questions you can answer? Okay, you. See how the director used the actor in the movie. Okay, so I think I probably need a little more detail to make that a rigorous question, but there's probably questions like, which directors liked which actors, okay? It's probably the case today where certain actors or directors have certain actors they use over and over again, right? It's not a kind of a random thing which actors appear in which directors' movies, okay? And there's certainly a phenomena there to study. Okay, so who makes bank? Okay, which actors gross the most money? Okay, which directors make the most money? Yeah, which films make the most money? Right? Because I think it showed the cost of making the budget for the movie and the amount of money. So there's a question of profit, right? Okay, let's see who else is new. You. Who are the top actors in each genre? Okay, so you can imagine that certain actors appear in comedies and certain actors appear in adventure films, things like this. Okay, what else is there? Let's say you.
Yeah, so we can see how the chemistry between the actor and actresses affect the IMDb rating or the income.
So there's things about you saying about chemistry between actors. Again, we don't get. Data is not fine-grained here to tell me about what?
We can measure the chemistry by correlating actor and actresses with the score, IMDb rating.
Okay, so there's a question of how good people are. You remember, you get two different things. You get something about how much money they make. You also get a score as to how good the film is. Actually, how good was It's a Wonderful Life? It was a top, at this point it was an 8.7. That's very good. And a top 5,000, one of the 5,000 best films made by them. So there's questions of, the quality of the film by the public. In fact, you've got ratings from all the different people, okay? So that's something. Any other things you can do with this? Yes?
How the people's interest changes over time. How people rated comedy and romantic.
Okay, so there's interests about how things change over time. How is it that actors age? What is the shelf life of an actor or actress when them being able to, to be in movies, okay? And how does that change? Do these guys have long careers, short careers? What's the distribution of that kind of thing? That seems like something to take a look at.
What are top, for example, 5 actors who won, the most Oscar prizes or something?
Okay, so you said about prizes. Can you look at something like who gets the prizes? Okay, and you measure actor quality by prizes. What did the prizes mean? Did the prizes mean the movies were good, or did the prizes mean that the movie made money? Okay, that feels like a phenomena. Yes?
Based on the release date of the movies, we can find out what time is a good time to release.
When is a good time to release a movie? So historically, Christmas is a good time to release a movie in the United States. Why? Because people are going to go on vacation. They have nothing else to do but watch the movie. Okay, so how does gross affect as a function of movie? Let's try for any. I want to see some new ones. Yeah.
What is the most inspirational movie for certain people?
What is the most what?
Inspirational movie.
Inspirational movie. If you have a way of measuring, the question is how do you measure inspiration?
Preferences like his time or his situations in life.
Okay, so you'd like to be able to measure the influence or importance of movies, okay, or how much it affects people. It's not clear that that data is in this set, okay? That might be a world where you have to somehow get some kind of external data about what people are talking about, who, maybe you went over the web and how often people talk about. And maybe if you looked at the reviews, that would be maybe one way to tell. They have these reviews written on the website where people write about what they think of the movie. And if they said, this movie changed the way I think about the world, and now I feel great about the world. That's an an inspiring film to them, and maybe there's ways of measuring it. Okay, you.
How the actor correctly play the role of the character?
Say that again.
How the actor correctly plays.
How the actor correctly plays it? Again, you'd like to know this. How you can tell this from the data, I'm not as sure. That may be an interesting question. You know, is the actor doing a good job or a bad job? It's not clear whether that's being measured directly in here. Maybe in the comments, if you read the reviews, if someone said Jimmy Stewart was unbelievable in this, okay, maybe that was but so anyway, you have to make sure you have that thing. And let's try last one, you. Yes, you.
I look at the parents guide often. My hypothesis is that family-friendly movies are rated lower than if they are.
Okay, so there's a question of, you have family-friendly movies, you have dirty movies. Which one do people like better? Okay, which ones make more money? Okay, maybe that's a question. Okay, so what kind of questions did I come up with? Okay, well, certainly you'd like to be, if you were a movie maker, you'd like to be able to figure out, is a movie going to be a success or a failure? You know, people invest $100 million these days making a movie. Is it going to be a success or not? Can you predict based on what the cast is and what the story is and stuff like that? Okay? Will people like it, and will it make money? One interesting source of the of data from the movie data set is that it gives you a social network. Okay? You know, if two people appeared in the same movie, they presumably met each other, they got to know each other, they got each other's phone number, they presumably, you know, have a social connection to some degree. Okay? Now you can look at the social network of actors and actresses and start to study it in ways. First of all, this is a visible social network. I can't get Facebook's network of everybody. I can get, IMDb's network of everybody. Okay, there was a game that was popular for a while called 6 Degrees of Kevin Bacon. Who was the actor that was most central? That every person could be either was Kevin Bacon or had made a movie with Kevin Bacon or had made a movie with someone who made the movie with Kevin Bacon. You could measure your Bacon distance. Who was the most central actor of all, who minimized the average distance to all other actors? These days, actually, it was Samuel Jackson, is what I understand, okay? But it means appearing in a lot of movies with a lot of different people helps you out. What is the age distribution of actors and actresses in films? Who are older in movies, men or women? Men are older, okay? Historically, women are younger in movies, okay? And we can argue why that is, but we assume that that it's certainly not an equitable thing. What does the age distribution of this thing look like? What is the age distribution of couples in movies? Is an interesting question. That there's a 100-year-old Harrison Ford is going to be married to a much younger actress in any kind of a movie that he's in. There is this question of, do actors live longer and shorter lives than most people? On one hand, what do you guys think? Do actors live longer or shorter than the average person? Shorter, you think, sex, drugs, and rock and roll type of thing, that they live hard lives and they all overdose or something like that. Maybe that's true. Is it true for the stars? Is it different for the stars or the bit players or what? Okay, these become interesting questions. Any questions about actors and actresses? That data. Okay, I think we're still going okay. Okay, let's look at a third data set. Okay, one is this one I mentioned the first day of class on Google ngrams. Okay, now how many people have people ever gone to Google ngrams on the web? Who's done that? A small number of you. I encourage people to play with it. I find it fascinating. Okay, you basically can get a time series of how often any popular enough short phrase, short means 1 to 5 words, popular enough means occurred more than 40 times in scanned books in history. Okay, you can see how much has Stephen Skinner occurred in books. My name's occurred more than 40 times. Somewhere I'm on there. Maybe at some point I was an important person and now no one's talking about me anymore. Okay, you can see the graph. Okay, you can see these things. Now Google scanned 15% at the time I wrote the slide. It's probably much higher now, just because more and more books have been published, and and this is always going to increase. So we know a lot about what phrases have been used in books as a function of time. So here's an example. This is showing what happened if you want to look at 3 famous people: Albert Einstein, Sherlock Holmes, and Frankenstein. Okay? How much were they talked about? The x-axis is year. The y-axis is a measure of what percentage of the text in scanned books is that term. Okay, when you normalize it in a right way. Why was it that Sherlock Holmes was never talked about until it looks like 1890? Can anyone figure out why he was never talked about? What, he's a fictional character, and why did no one talk about him before that? They never wrote the book, okay, so he didn't exist. But then he became popular. Albert Einstein, he had to be born at some point. Frankenstein goes back a longer way, right? Okay, people familiar with Frankenstein? Okay, anyway, Frankenstein suddenly became very popular in the mid-1960s. Can anybody think of why? A movie came out. Actually, the movies that are most famous for him came out in the 1930s. So actually, that's not quite the right answer. It could have been an answer. Does anyone know? Yeah?
Did it become part of the English language?
It became part of the English language, right? Frankenstein was this human-created monster that was threatened to take over the world in some sense. So people talk people talk about AI as a Frankenstein, technology. Okay, it's going to eat the world. It's going to kill us all. Okay, when it became a metaphor, it suddenly shot up. Right? Does everybody kind of see that? You can see these trends by reading the Google ngrams thing. Now, what can you do if you know about how often every short phrase has appeared in scanned books over the last 200 years? What can you do, and what can you hope to learn from that? Okay, yeah?
How relevant the word is.
For any word, you can measure how popular it is. Okay? There's some words that have probably become less popular with time. Okay? People used to talk about thee and thou. They probably don't use that so much now. Okay? So part of that is true. What other things can you do with Google ngrams? Okay, I'm not here. Yes?
Prediction of relationship between the length of the words and their popularity.
Okay, that's an interesting question. Now, how does the length of the word match its popularity? Okay? Now, if you study information theory, has anyone ever studied any information theory? Okay? Entropy, information theory, things like that. You would expect if you want to optimize communications, you use things like Huffman codes. Do people learn about Huffman codes these days? Yeah? You would think that you'd want short words to be the ones assigned to most frequent things, right? And long words should be assigned to infrequent things, right? To what extent is that true? You need to know the length of words. Well, that you can measure by, counting letters. This is not something, if I have a table of words and I know how much their frequency of being used every year is, I can now study this kind of phenomena. That seems like an interesting question to study. And is it getting better or worse? Okay? Is it that now, there's been a lot of words created over the last 200 years? Are people filling in? Is it that newer words are long because shorter words have all been taking all the slots? Okay? Or is it that we start reusing short words to, to, if we have new big concepts? It seems like an interesting phenomena to study, okay? So, a good data scientist would be itching now to say, yeah, that'd be a great project in this course, okay? Yes?
What words are popular within what time periods? Like
What?
last year, yesterday, has to be popular. Maybe 10 years ago, the stock market crashed.
So what is the popularity duration of words, right? That there are some words that are hip. Do people know what the word hip means? Okay? Is hip these days, or is that an old-fashioned term? If I see what is the frequency with which you're using words, okay, then this becomes an interesting phenomena. Is the turnover of words greater than it was before or not? This is the kind of thing that you could study from this. That becomes hard to tell. It's different. This gives you a way to look in the past. Normally when you're collecting data, you say, I can collect data on word use today, but how do I go back in time? What's amazing about this is by looking at the old books, you can go back in time. Okay? Anything else? Yeah.
Are there any foreign words in a foreign language which are used very often?
Are there foreign language words that are creeping into let's say English? Okay? How is it that are English words creeping into foreign languages and foreign languages creeping into English? Okay? They claim to produce data sets where they separate this out. Like, they try to recognize the source of the language, and they will give you let's say, based on English books versus German books and things like that. So the answer is yes. Studying the transfer of words across languages might be interesting. Okay? Anything else come to mind? You.
How often new words replace pre-existing synonyms?
Say that again, I'm sorry.
How often new words replace pre-existing synonyms?
Right. Okay, so the question of new words versus synonyms. Now, how often are new words created? This I see how to do. This is just counting, right? You're looking at this. If I look at the graph, Sherlock Holmes got created. Why do I know that? His count was 0, and now it's larger. Okay, so I know when Sherlock Holmes got created. You say something about synonyms. How do I tell if two words are a synonym? This now is a harder thing, right? Does everybody see this is not a direct counting problem now? Maybe I have to use dictionaries or thesauruses or something like that, or maybe more modern LLM type technology for that. But that starts to be a different kind of question to ask. Okay, one more.
Predict the next word.
What?
Predict the next word.
Predicting
The next word.
the next word. So you could use this as training data for an LLM. This is a good thing. They undoubtedly do, but that sounds like a computer science-y thing and not a data science-y thing. What were my questions for this? One was, how much has cursing changed over time? You guys are used to some words that I know are dirty words, right? How often are people using dirty words in books more now than they used to? I have a feeling they probably did. One interesting study is how long do technologies last and people be famous? This changes. Okay? These kind of questions. Okay, the last data set I want to do, I think I have 4 minutes left, is a data set on taxi cabs data. In New York, if you have money, you can get into a taxi cab, and that cab will take you someplace, right? People familiar with this idea? Okay. Turns out that when you get into a cab, there is a meter, a legal cab, there is a meter, and they keep track of every cab, every pickup and drop-off it makes, and how much money the fare was. And this data actually can be obtained from New York City. It's now someone put it on the web, but it was produced by a government agency. In the United States, government agencies under certain conditions, have to make their data public? What can you do if you know every pickup and drop-off of every cab ride in New York City? What could you hope to do with data like that? Yeah?
You can figure out what's the most common place people getting picked up.
Where do people get picked up? Where do they get dropped off? Right? What else can you do? Number of pickups. How hard, I would say, by cabbie, how much, one thing I'm curious about is for each cab driver, how many people do they pick up and drop off every day? Okay? Yes. Which neighborhood has the most traffic? So notice that you know something about the time how far they went. You know where they were picked up and where they were dropped off. From that, somehow you can figure out something about the speed of the trip, right? Why are rides slow? Do rides take a long time? Usually it's because of traffic. Maybe that the cab driver's taking you for a ride since he pays you you pay by the minute. But usually it's because of traffic, right? So this is actually a proxy for how busy roads are at certain times, okay, that you get to have. That's now interesting. Okay, yeah?
Correlation of area where the fare was picked up and the driver's income.
Okay, so how rich is the driver? How much does the driver get depending upon where they are? One thing that you should know if you're a real New Yorker, what color is a taxi? Yellow. They're not all yellow. What other color is a taxi? Green, okay? If you got picked up in a green taxi, what does that mean? What? You were picked up in a poorer neighborhood, okay? That the green taxis are licensed. They were given easier licensing terms, but to make sure they serve certain communities that weren't otherwise getting served, okay? So, you know, you get things like this. So what questions did I think about taxis that you could learn from this? Again, how far does a taxi go? How much money does a taxi driver make? Where is it slow? Where do people go? What are bigger questions that you can think about? One question I was curious about is how well does you get the size of tips on this thing? Do people drivers get tipped more when they ride faster? Okay, historically that's morally the way it should be. Okay, do people tip better in good neighborhoods or bad neighborhoods? Okay, you can believe the rich people may be cheapskates. It's not clear to me that that works out. But this is something you can figure out. Okay, any questions about that? Okay, so the lesson for today, if you have data sets, there are lots of interesting things you can do with it. For the rest of the semester, hopefully we'll learn how to do things with it. Tonight, get on, if you're not on Piazza, get there. Tomorrow, expect the quiz, and we'll deal with it. Last question. How can you access the lecture recording? I am told that the lecture recording is on Brightspace. Does this information help anybody? Okay, if you don't know, what should you do now? If that you still can't find it, you should ask on Piazza and say, where do I find the lecture recording? And quite likely one of your classmates will say, get on Brightspace and click on this. Okay? Thanks a lot. See you guys on Thursday.